For the last part of this chapter, I decided to give you a couple of challenging integrals to do by hand because that's what chapter 8 is all about, doing very difficult integration problems. So I figured let's get kind of warmed up for chapter 8. So problem 1, f of x is equal to the square root of 9 minus x squared, or 9 minus x squared to the half power. Find the derivative f prime of x is equal to half, and I changed 9 minus x squared into the negative 1 half power by subtracting 1 from a half. And don't forget the chain rule, so that's times negative 2x. Simplifying a little bit, we have the derivative is equal to negative x times the quantity of 9 minus x squared raised to the negative half. So we have r of x we have to determine, and r of x is a radius. So if you look at the spinning rectangle, it'd be spinning down and towards you, would give you the radius, and that radius is determined by the function, which is the square root of 9 minus x squared. So pulling out your formula for surface area, we have 2 pi integral of r of x, again, which is the radius function, times the square root of 1 plus the derivative squared. So that's like an arc length piece. And say if surface area is equal to 2 pi integral from negative 2 to 2 of 9 minus x squared quantity being raised to the half power times the square root of 1 plus that derivative we found, negative x times 9 minus x squared to the negative half, and that's being raised to square. So it's very difficult at this point to do this problem. So we'll have to see how we do this one. So the first thing I chose to do was to get rid of any negative exponents. So we have 2 pi, integral from negative 2 to 2. We have that 9 minus x squared being raised to the half power. That didn't change. Square root of 1 plus, and here's the change. We have negative x over 9 minus x squared being raised to the half power. Essentially, I took that 9 minus x squared to the negative half power, brought it down below. That again is being squared. In the next step, first pieces are the same. We scoot to the back, we have the square root of 1 plus. Now if we square negative x, we get x squared. Now, if we square 9 minus x squared to the half power, we multiply exponents, we just get 9 minus x squared. Then we say, okay, what do we got with that? Well, we have to find a common denominator to combine those two fractions. So again, the first pieces are just hanging out there waiting for us to do more work. Common denominator is 9 minus x squared. So 1 is the same as 9 minus x squared over 9 minus x squared, because that's an equivalent form of 1. Add on that x squared over 9 minus x squared, since we have a common denominator. The negative x squared and the x squared will add together and disappear, and we just have a 9 on top. So we still have that front piece being the same, but now we have the square root of 9 over the square root of 9 minus x squared. So we have the square root of 9 becoming a 3, bringing that 9 minus x squared to the half power from the front and combining with that 3. And we have the square root of 9 minus x squared on the bottom, which turns into a duplicate 9 minus x squared to the half power, which is why this problem can be done by hand. That crosses out, and we get 2 pi times the integral of a 3 dx. A 3 is simply 3x, so we have 2 pi times 3x being evaluated from negative 2 to 2, and we get 24 pi. Nasty problem.